All right, welcome back. Today we are going to talk about 1.5 complex numbers. So we're going to look at principal square roots, imaginary roots or complex roots, and then we're going to look at complex numbers. So what happens when we get the square root of a negative. So I'll take you through that today. Then you'll have your homework for 1.5 day 1. So starting off here, just principal square roots, that is the positive root. So you can see here, square root of 16 is 4, square root of 100 is 10, square root of 36 is 6. Those are the principal roots. If you want the negative root, then we will put the negative in front, and that specifies that you want the negative root of square root of 16, which in this case is negative 4. Same thing here if you have an irrational root that's going to give you a decimal. So square root of 71, the principal root is approximately 8.43. The negative of that is negative 8.43. If we have the square root of a negative, that is going to be a non-real or imaginary number. Complex root, we will get to that later today. So that will help us when we get to factoring and so forth. We'll see that in day 2 with how we handle that. Okay, imaginary numbers. So by definition, we cannot take the square root of negative 1. That is undefined. So what we do is we define this with a new number that we call I, or imaginary number. So the square root of negative 1 is now defined as I. If I were to take the square root of negative 1 times the square root of negative 1, that would in turn be I squared. Or we could say that I times I is I squared. And for our purposes, I squared will equal negative 1. Why is that? Well, if you take a square root times itself, the square root cancels out. And so I squared equals negative 1. And again, that will help us as we simplify negative square roots moving forward. Okay, for example right here, square root of negative 25. Prior to today, this would be undefined, no real roots. What I can do is separate this into a product. So this is really the square root of 25 times the square root of negative 1. We know that the square root of 25 is really 5, or plus and minus 5, if you will. And the square root of negative 1 we have now defined as I. So our answer is plus or minus 5I. Give you a second example. I'll get to this one in a moment. So again here, square root of negative 81 is the square root of 81 times the square root of negative 1. We know this square root is really plus or minus 9 times I, so plus or minus 9I. If we have a non-perfect square, we can do the same thing. So this is really the square root of 5 times the square root of negative 1. This is a decimal approximated to 3 decimal places, so plus or minus 2.236 times I. So again, the I, or the imaginary root, lets you know that this was the square root of a negative. Little number theory here, but this will help us out again to understand this. If you take a square root squared, if we write out the long way, that's really this. And we know 5 times 5 is 25. But really, square root times square root, you get the number that's under. So square root of 5 squared, you can skip all this here, it equals 5. Square root of 5 squared does not equal negative 5. It only equals positive 5. So if we want a negative, we have to do this. We have to take the negative, or square root of negative 5 squared, if we want to get negative 5. And again, the basis for that is in this I squared. I is the square root of negative 1. I squared is negative 1. So again, if I square this, I am going to get negative 1. So I squared is negative 1. That will hold true throughout the remainder of the year as we go to simplify these expressions. Okay, complex numbers. Complex numbers are any number that has an imaginary number in it. It's in this form, a plus bi. A representing the real number, and then the bi representing the complex part. You can have rational numbers. You can write them as complex. So I could say 7 plus 0i, which we just call 7. any rational number is technically also in complex form. It's just plus 0i. We just typically don't write the plus 0i. These are known as conjugate pairs, each one that you see here. Notice they all have the same first number. The difference is in the imaginary part here. I got 5 plus 3i, 5 minus 3i, 6 minus 2i, 6 plus 2i. So the I numbers are opposites. That's why we call them conjugate pairs. Again, we're going to use this for simplifying in just a few moments. So a conjugate pair will always have the same first number. The sign on the imaginary number will be opposite. And your first number here, the a value, can also be negative. So you see this one here, negative 5 plus 7i, negative 5 minus 7i. Okay, simplifying, no different than any other variables. You combine like terms. So real numbers combine with real numbers. In this case, our numbers that have an I, we combine with each other. So in this case, 7 plus 1 for 8, 4i plus negative 2i for 2i. So 8 plus 2i. And we always put the real number first. So put it in the form a plus bi. Real number first, and the imaginary number after that. Okay, second example, 15 plus 8 for 23. And we add the I terms, 23 minus I. Last one down here, I distributed the negative. You didn't have to, but I made it negative 8 minus 5i just to make it a little easier. So this is going to be 7 minus 11i, like so. So again, you combine like terms here just like you would any other variable, a, x, t, y, whatever variables you have. Same thing holds true with imaginary numbers. You combine them just like you would any other like term. Multiplying, same idea. We distribute same as we ever would. So even if this was 5 plus 3x, we do it the same way. So 4 times 5 for 20, 4 times 3i for 12i. 6 times 2i for 12i plus 42. Again, we want to rewrite that. You want to put this in the correct order. So we do need to write it as 42 plus 12i. You always want to have your complex numbers in the form real number a plus the imaginary number bi. You can FOIL these as well. So here you see 3 plus 2i squared, which is really 3 plus 2i times 3 plus 2i. You all know how to FOIL, but we'll go through it. So first term, 3 times 3 for 9. Outside terms for 6i. Inside terms for 6i. And when we do 2i times 2i, we get 4i squared. Now, if you remember from a few previous slides, I squared is negative 1. So this number right here can really be simplified to be 4 times negative 1 or negative 4. So again, 4i squared is 4 times negative 1, which is negative 4. Now I can combine my like terms, 5 plus 12i. So again, you would distribute or FOIL this out. No different if it was 3 plus 2x times 3 plus 2x. The only difference is I squared can be simplified. So that really becomes 4 times negative 1. Just like we did with regular polynomials earlier in the year, if you prefer, you can use the box method. We get the same answer here, so you see that. So 3 times 3 for 9, 3 times 2i, 3 times 2i, and 2i times 2i. Fill in the box, combine your like terms. So again, if you prefer that, you can go right ahead and do it that way, or you can show it the traditional way like so. That's your call. Notice here these two are conjugates. So you know what happens here when we FOIL and we have opposite signs. The middle terms should cancel out. So we got 5 times 5 for 25. You see our outside term, negative 15i, inside term, positive 15i, minus 9i squared. So again, indeed, these middle terms cancel out. So I end up with 25 minus 9i squared. I squared, remember, is negative 1. So this is really plus 9, as you can see over here. So 25 plus 9 for 34. One final example today, then that'll wrap up today's notes and lecture, and you'll be ready to go for day one of the homework for this section. Okay, again, we're going to FOIL. The middle terms are going to cancel out again. What's slightly different about this is you see these square roots. So we'll put this all together. Square root of 7 times the square root of 7 is really 7. When I do the outside term, square root of 7 times the square root of 13 is square root of 91. That's going to be minus, and the inside term here is going to be plus. Now you can write the I after the square root like it is here, or you can put the I in front. That doesn't matter. What I want you to see here is these middle terms, again, are going to cancel out. When I take the square root of 13 times the square root of 13, those are going to cancel here. I get negative 13i squared, which will simplify to plus 13. So bottom line is our answer is 20. So that concludes the notes for today. Feel free to rewind, go back, do what you need to do. Today's homework assignment is going to be 1.5 day 1, and then we will get into day 2 tomorrow. Got any questions, hit me up with an email. Enjoy the rest of your day, and we will see you tomorrow.